All right, so I'm just going to go over sections 2.1 and 2.4 just that you guys have for review. You guys already took this test. You guys already were already assessed on this material, but I think it's important for you guys to be able to understand this part, right? Everything that we do from here is going to build on this. So I'll go question by question. I'm going to answer every single question in this video, right? So I'll start with section 2.1. In this one, we covered one-step equations, right? These are some of the easiest ones that you're going to see, right? All you have to do in these kinds of problems is isolate the variable by performing the inverse operation, all right? And now the inverse operations, if you remember, right? So if we have an operation, right, the inverse operation is just what we need to do to undo the operation that is being done, right? So if we have addition as an operation, its inverse operation is going to be subtraction. So to get rid of something that's being added, we want to subtract. Similarly, if we have subtraction as an operation, right? If something is being subtracted, we get rid of that by adding. So the inverse of subtraction is addition. All right, and now multiplication is another one of our operations, right? And to get rid of something that's being multiplied, we want to divide, or division. All right, and then if something is being divided, right, so if we have division as an operation, its inverse is multiplication. All right. Again, I went over this with you guys in class before your test. All right. So again, if by now you're still not fully comfortable with this lesson, right, that's what this is for. All right. So let's do some examples. All right. That's the best way to get better at these problems is to do examples. All right. So number one, we see 2x equals 16, right? If you remember, 2x is the same as 2 times x, right? And our inverse of multiplication is division. So to get rid of this 2 that's being multiplied, we want to divide by 2 on both sides, right? Because 2 divided by 2 is 1, and so it goes away. And so you get x equals 16 divided by 2, which is 8, right? Just one single step in this problem. All right, and then the second one is another one-step equation. We have d divided by 8 equals 10. Right, if it's written like this with the fraction bar, that means division. Right, so to get rid of something that's being divided, we want to multiply. So we're going to multiply both sides by 8. Right, so times 8 here and times 8 here. Right, because what you do to one side, you have to do to the other. Right, that's what's going to keep this equal sign an equal sign. All right, so once we multiply 8 on both sides, 8 divided by 8 goes away. Right, just like the last one. So we get d equals 10 times 8, which is 80. All right. Now looking at the next one, we have w minus 12 equals 20. All right, so what operation is being done to this w? Right, we want to isolate the variable in all of these. Right, so here we have a subtraction, right? W minus 12, right? The opposite of something that's being subtracted is addition, right? We want to add 12 on both sides. And then minus 12 plus 12 is going to go away. That's going to become 0. All right, so we get w equals 12 plus 20 is going to get you 32. All right, just one step here, right? In all these problems, you're doing what's going to get the variable isolated, right? That's the main goal here. And for this one and for all of these, we want to isolate the variable. All right, so looking at number 4, we have y plus 18 equals 10. Right, so what operation is being done to this y, right? We want to isolate the y. Is plus 18, right? So opposite of plus 18 is minus 18. So we're going to subtract 18 on both sides. And then plus 18 minus 18 is going to go away. And then 10 minus 18, if they have different signs, we want to subtract. So 10 or 18 minus 10 is going to be 8, and then keep the sign of the bigger number, which is negative. Right, this negative 18 is bigger. Right, so we get y equals negative 8. All right. Now looking at this next one, we have the numbers and variables in a different order. right? So we have a -4, and this is being added to the m, right? This m is the variable that we want to isolate. So now we just want to think, how can we get rid of a -4? Right, to get rid of a -4, we want to add 4 on both sides. All right, and then -4 plus 4 goes away. Positive m just stays m, and then m equals 19 plus 4, which is 23. All right, and then same thing with this next one here. Right, if 6 plus p equals -11, right, p is the variable that you want to isolate, and you have 6 is being added to it. Now the opposite of a positive 6 is a -6, so we want to subtract 6 on both sides. And then 6 minus 6 goes away, and you're left with just a positive p, equals -11 minus 6 is going to get you -17. When they have the same sign, you want to add and keep the sign. All right. And then this one right here, right, this one was a little bit tricky for some of you, right? If I have 3/2 times x, right, remember, if there's no operation, it's a times, multiplying, equals 12, we want to somehow get rid of this fraction because the x is the variable that we want to isolate, right? And so weeks ago, we covered what we need to multiply a fraction by to get 1, right? And it's by its reciprocal. So if you remember, the reciprocal of a fraction, you just flip the top and the bottom. Right, so here we just multiply both sides by 2/3, right? 2/3 is the reciprocal of 3/2, right? And then 2/3 goes away, all right? And then we get x equals 12 times 2. Remember, with a fraction and a whole number, the whole number we can treat like a fraction by putting it over 1. And then we just go straight across, right? So 12 times 2 is 24. 1 times 3 is 3. And then 24 divided by 3 is 8. So we get x equals 8. All right. And now for number 8, we have n divided by -5 equals 9. Right? And the opposite of dividing by -5 is multiplying by -5. So you want to multiply by -5 on both sides. All right. So the -5 and the -5 cancel, and you're just left with your n. And then n equals 9 times -5 is -45, right? Don't forget your sign here, right? Negative times a positive is a negative, always. All right? Same thing with number 9, right? I have a -7 times x equals 84. Opposite of multiplying is dividing. And then -7 divided by -7 goes away. And then we just have an x equals 84 divided by -7 is -12. Right, again, positive divided by negative is negative. All right, and so that's our one-step equations. Now, in the second section of this lesson, we did two-step equations. And we did PEMDAS backwards, right? So we still want to isolate the variable, right? We want to do this to isolate the variable, right? And to isolate the variable, we're doing PEMDAS backwards, right? So essentially we're doing SAD MEP, something like that, right? We want to do any subtraction and addition first, then we move on to division and multiplication, and then we take care of the exponent in the parentheses. All right, so let's look at number 1. All right, so 6x minus 3 equals 9. So you want to isolate the variable. Our variable here is x, right? And in our two-step equations, these are equations that we can solve for x by performing the order of operations backwards. So is there any subtraction or addition happening to this x right here? There is, right? There's going to be this minus 3. So the opposite of a minus 3 is a plus 3, and we want to take care of that first. All right, so plus 3, and then we get 6x equals 9 plus 3 is 12. All right, and that was our first step, and our second step has to be any multiplication and division. Right, so 6 times x, opposite of multiplying by 6 is dividing by 6. So we get x equals 12 divided by 6, which is 2. all right? And when you look at number 2, 17 plus 2p equals negative 11, right? P is our variable here that we want to isolate. So we want to do order of operations backwards, right? PEMDAS backwards. Any addition or subtraction, there should be a 17, right? So to get rid of that 17, that positive 17, we want to subtract 17. And then 17 minus 17 goes away. So we get 2p equals negative 11 minus 17. They have the same sign. They're both negative. So we want to add them and keep the sign, right? So 11 plus 17 is 28. And they're both negative, so it's going to be a negative 28. All right. And then the next thing we want to do, 2p is the same as 2 times p. And the opposite of multiplying by 2 is dividing by 2. All right, and then negative 28 divided by positive 2 is going to be negative 14. All right. And now when you look at number 3, similar story here, right? This should be done in 2 steps, right? G is our variable that we want to isolate. So G, what's going on to the what's happening to this G, right? It's being divided by 4 and 23 is being added to it. So first we want to take care of any addition and subtraction. Let's subtract this 23 first on both sides. All right, so then we get G over 4 equals 16 minus 23. All right, if they have opposite signs, you're going to subtract. 23 minus 16 is going to give you negative 7. All right. And then to get rid of this dividing by 4, right, we want to multiply by 4 on both sides. And then we get G equals negative 7 times 4 is negative 28. Again, don't mess up the signs, right? Positive divided or positive times negative is negative. All right. And now number 4, this one's a little bit different because now our variable is still up there, right? We still have a variable, but now we have something that's being divided. So this 6 is being divided to the entire expression here, right? So we can't really get rid of this plus 4, or no, we can't really get rid of this minus 4 by doing plus 4 on both sides yet because it's being divided by this 6, just like this m is, right? So the first thing we actually want to do is get rid of this 6 that's being divided. So we want to multiply both sides by 6. So times 6 times 6. And then this 6 and this 6 go away, and then we get negative 4 plus m equals 11 times 6 is 66. All right, and now we can get rid of that 4, or that negative 4, right? Opposite of negative 4 is plus 4. So then we get m equals 66 plus 4 is 70. All right, and I'm going to go ahead and jump to number 6 because that's exactly the same thing, right? We have a 12 on the bottom, right? And that's dividing the entire expression up here, right? So even though r is the variable that we want to isolate, we can't isolate it until we get rid of that 12 on the bottom since it's dividing the entire expression. So let's go ahead and multiply 12 on both sides. All right, and then 12 divided by 12 goes away. We get r plus 21 equals negative 7 times 12 is negative 84. And now we can get rid of that, that 21. All right, opposite of adding 21 is subtracting 21. All right, so we get r equals negative 84 minus 21. They have the same sign, so we want to add. All right, so it should be 105, and it's negative, right? So negative 105. All right. So that's how you handle those kinds of problems. So I'll just go through all these other examples, right, just to finish this page up. All right. So number 5, we want to isolate our y, right? And so we're doing PEMDAS backwards, right? This 6, we can subtract the 6 on both sides to get rid of it, right? Because in this case, 12 is only dividing y. It's not dividing y plus 6. So we can immediately get rid of that 6. So we get y divided by 12 equals negative 2 minus 6 is going to give you negative 8. Right? Same sign you want to add and keep the sign. And then the opposite of dividing by 12 is multiplying by 12. So let's multiply by 12 on both sides. Okay, and then negative 8 times 12 12 is going to get you negative 96. All right. And something like number 7, right, is similar to one of the problems that we did in the one-step equations, right? So first, let's get rid of that negative 3 by adding 3, right? Our order of operations backwards. Get rid of addition and subtraction first. So we get 1 over 9 n equals negative 13 plus 3 is negative 10, right? Different signs, you subtract and keep the sign of the bigger one. And then how do you get rid of a fraction that's being multiplied, right? What do you need to multiply this fraction by 1 over 9 to get 1, right? For it to go away. It's by its reciprocal, right? And the reciprocal is the same fraction, just flipped. So multiply both sides by 9 over 1. All right, but 9 over 1 is the same as just 9, right? Anything divided by 1 is itself. So you can just get rid of that on the bottom. And then you're just left with n equals negative 10 times 9 is negative 90. All right. And then number 8, again, we want to get the c by itself. All right. So let's get rid of any addition and subtraction first. Let's subtract 3 on both sides. All right, and then 3 minus 3 goes away. We're left with 1/7 times c equals negative 7. And then just like the last one, to get rid of 1/7, we want to multiply by its reciprocal. Right, so let's multiply by 7 over 1. But again, 7 over 1 is just 7. So multiply by 7 on both sides. All right, so then this side cancels out. Then we get c equals negative 7 times 7 is negative 49. All right, last one on this page. All right, this time the 5 is dividing the entire expression. All right, so let's get rid of that 5 first. Let's multiply by 5 on both sides, right? This 5 is dividing. Get rid of dividing by multiplying. So we get 2 plus d equals 4 times 5 is 20. And then we want to get rid of that 2 in front of that d. Right, so let's subtract 2 on both sides. And then 2 minus 2 goes away. We get d equals 20 minus 2 is 18. All right, so now we get into the next section, which is our multi-step equations. All right, and I have an example problem up here. The first thing you want to do in any multi-step equation is to distribute if possible, right? I write that there because not always are you going to have to distribute, right? Same thing with the second step, combine like terms. Again, if possible, you're not always going to have to do it. And then it's going to work exactly the same way as our two-step equations, right? We want to isolate the variable by doing PEMDAS backwards. All right, here's our example, right? So we have 2x plus 3 times 3x minus 10 equals 14. The first thing we want to do is distribute, right? In this case, we're able to. How can you tell when you can distribute? Is if there's a number in front of a set of parentheses like this one. All right, so this is 3 times 3x minus 10. All right, so then we want to distribute that 3. So then we get 3 times 3x minus 3 times 10 is going to get you 2x plus 9x minus 30 equals 14. And then we want to combine like terms. In this case, our like terms are going to be 2x and 9x. And then that's going to give you 11x, right? Like terms either have the exact same variables or are just constants, right? Have no variable with it. And then you want to do PEMDAS backwards, right? So you want to add 30 on both sides to get rid of this minus 30. All right, cancel it out, and then we get 11x equals 44. And then you want to divide by 11 on both sides, and then you get your answer, x equals 4. All right, so the hardest part here is these first two steps, right? Knowing when to distribute and knowing when to combine like terms. All right, so I'll do some examples with you guys. All right, first example. The first thing that you always want to check, is there anything that you need to distribute? All right, well, you don't see any parentheses here. All right, so there's nothing to distribute. Now, are there like terms to combine? Right, you want to look on each side of the equal sign. Right, so I maybe showed you guys in class, right, to kind of divide the equal sign so that you don't get confused and say, okay, well, there's a -9 and a 15 or a -6 and a 15, and try to combine those right away. No, you can only combine on one side of the equal sign. All right? And on the left side of the equal sign, we have a -6 and a -9, right? And then that becomes -15, right? You can combine these. These are like terms. They don't have any variables attached to them, so you're able to just combine them. So we get -3n, and -6 minus 19 is -15, all right, equals 15. And now on the left side of the equal sign, there's no more like terms to combine, right? So we want to do PEMDAS backwards, right? Get rid of any addition subtraction first, so let's get rid of that subtraction. All right, -15 plus 15 goes away. We get -3n equals 15 plus 15 is 30. And the last thing we want to do is get rid of any multiplication and division, right? So let's get rid of that multiplication by dividing by 3. So we get n equals -10. All right. All right, now let's check the second one. All right, we have -16 equals -6 plus 2 times x plus 4. The first thing you want to do, is there anything that you need to distribute? All right, here there is, right? There is a 2 in front of a set of parentheses. So you're distributing that 2 to everything. So we get -16 equals -6 plus 2 times x is 2x plus 2 times 4 is 8. All right, don't get confused and do -6 plus 2 is -4 and then distribute a -4. Right? No, you have to distribute first. That's the first thing you do. And then in your second step, you can combine like terms. Again, on only one side of the equal sign. Right? On the right side of the equal sign, there's a -6 and a +8. Right? Are the like terms, right? Those are the only two things on this side of the equal sign that don't have a variable. Right, so you're able to combine them just as normal, right? -6 plus 8 is +2. And you can write that anywhere in the equation. So we get 2 plus 2x equals -16. And then you want to do PEMDAS backwards. So let's subtract this 2 on both sides. Then you get -18 equals 2x. And then divide by 2. All right, so we get x equals -18 divided by 2 is -9. All right. Now let's try the same thing with number 3. This one's a little bit similar to the last one, right? Is there any distribution that you need to do first? There is, right? What are we distributing? We're distributing this 2, right? We distribute this 2 to each term on the inside of parentheses. And so we should get 15 equals -3 plus 2 times x is 2x, 2 times 4 is 8. And then you want to combine like terms. Again, on this side of the equal sign is going to be a -3 and a +8. So we get 15 equals 5 plus 2x, right? -3 plus 8 is going to get you a +5. And then you want to do PEMDAS backwards, right? So subtract 5 on both sides. We should get 10 equals 2x. And then divide by 2 on both sides. So we get x equals 5. All right. And let's look at number 4. Right? Is there anything that we need to distribute? All right, not for this one. All right. Are there any like terms? There are. Right? We have a -9n and a +6n. Right? They both have an n, so they are like terms. To combine these like terms, you only combine the number in front of the variable. So -9 plus 6, all right, that's going to get you -3. All right, -3n equals -7. All right, and now to get the n by itself, you want to divide by -3. All right, divide by -3, divide by -3. And then you get n equals negative divided by negative always gets you a positive, right? So write it as a positive number. So n equals 7/3. All right, and there's nothing more you need to do to this. Don't change it to a mixed number. Don't leave it improper. All right, and it can't simplify, so you just leave it alone. All right. Number 5, similar story here, right? There's no like terms to combine. I'm sorry. There are. There's nothing to distribute in this one. All right, so if there's nothing to distribute, you want to then check if you can combine like terms, right? On this side of the equal sign, we have a 5x and a negative 6x. So 5 minus 6 is going to get you negative 1x, and then plus 8 equals negative 17. All right, and then to get the x by itself, we want to do PEMDAS backwards. So let's subtract 8 on both sides. So we get negative 1x equals negative 17 minus 8 is going to get you a negative 25. And then divide by that negative 1 on both sides. And there you get x equals negative divided by negative is positive, and 25 divided by 1 is just 25. All right. Next one. Same thing here. Is there anything we need to distribute? Not for this one, but are there any like terms to combine? There are, right? On this side of the equal sign, we can do negative 6 plus 8, and that's going to get you a positive 2. And then we still have negative 9r plus 2, and then equals negative 16. All right, and now we want to get the r by itself by doing PEMDAS backwards. So let's subtract 2 on both sides. We get negative 9r equals negative 18. And then you want to divide both sides by negative 9. So we get r equals 2. All right, let's keep going. Great, 7 and 8, again, just like the others, you don't need to distribute. But number 9 is one where you have to distribute, right? So let's do these again as normal. We have negative 4h plus 2 minus 3, combine like terms, right? 2 minus 3 is negative 1. So we get negative 4h minus 1 equals 31. All right, and then you want to add 1 on both sides. So we get negative 4h equals 31 plus 1 is 32. And then you want to divide by negative 4. So we get h equals negative 8. All right, don't forget the negative. All right, and then for number 18, or I'm sorry, for number 8, combine like terms, right? 7b plus 5b is going to get you 12b, and this equals negative 18. And the last thing we want to do, or next thing we want to do, is divide by 12. So we get b equals negative 18 divided by 12 is going to get you, you have to simplify this, right? So 18 and 12, do they share a common factor? They do, right? You can divide them both by 6. So you get b equals negative 3 over 2. And then you can leave it like that, right? Don't change it to improper. Don't change it to a mixed number, just leave it improper. All right? And then number 9. This one we do have something to distribute, right? We have to distribute this positive 3. All right? Again, do not combine negative 2 plus 3 and get 1 and then distribute 1. Right? No, the first thing you want to do is distribute, right? So you don't want to do that, right? First thing, distribute the 3. So you get negative 23 equals negative 2 plus 3 times x is 3x. 3 times negative 6 is negative 18, right? And then from here, you want to combine like terms. All right, and then negative 2 minus 18, they have the same sign, so you want to add them. You get negative 20 plus 3x equals negative 23. And then you want to add 20 on both sides. And then 23 minus 20 is going to get you 3. The 23 is bigger, so we keep it negative. Right, so we get negative 3 equals 3x. And the last thing you want to do is divide by 3 on both sides. And then negative 3 divided by 3 is negative 1. So we get x equals negative 1. All right, and then that's your multi-step equations. All right, so the last section in this review was solving equations with variables on both sides. All right, and the first 2 steps are the same as before. We want to distribute if possible, and we want to combine like terms if possible, right? Again, you're not always going to be able to do it. And then you want to move the variables to one side of the equation, and you want to move the constants to the other side of the equation, all right? And then from here, you can get your answer. There's going to be 2 special cases. All right, oh, looks like that should be 4, right? But there's going to be 2 special cases, right? So special cases right? The first one is going to be in all real numbers, and this is if the equation is always true. And you'll see what I mean when we get to that question. So the equation is always true. And then the second special case is no solution. And this is if the equation is false. Again, you'll see what I mean when we get there, right? So let's just try some examples. All right, so number one, we want to distribute first, right? So we want to distribute this 5, right? Again, distribute if possible. Here it's possible, right? So we want to distribute that 5, so we get on this side of the equal sign, 5 times 1 is 5, 5 times 6r is 30r, right? And on the other side of the equation, we have negative 27 minus 2r. And then we want to get the variables to one side of the equation and the constants on the other, right? It doesn't matter which side is which, right? You don't have to do the variables on the left or the right, right? It doesn't really matter, right? So I'm going to go ahead and move the minus 2r to the other side by adding 2r, right? And I'm doing this so that way, because I know some of you don't like dealing with the negative in front of the variable, right? So this is how we can get rid of that, because minus 2r plus 2r goes away, and on the other side, we have 30r plus 2r is 32r. And then we still have that 5, all right? So 5 plus 32r equals negative 27. And then we want to get the constants to the other, right? So get the minus 5 on the other side. And then we get negative 32 equals 32r. And then we want to solve. All right, so divide by 32, divide by 32. And then negative 32 divided by 32 is negative 1. Right, so we got r equals negative 1. All right. Same thing with the second one. Here we can distribute, right? We can distribute this 4. Right, so we get 30 plus 5n, right? That side of the equation doesn't change. And then 4 times 7n is going to be 28n. And then 4 times negative 4 is going to be negative 16. And then you want to get your constants to one side, variables on the other. All right, so why don't we subtract 5n? Right, so let's subtract 5n on both sides. And then we should get 30, right? 5n minus 5n goes away. 30 equals 28n minus 5n should be 23n. And then minus 16. All right, and then we want to get the constants to the other. All right, so let's add 16 on both sides. And then keep in mind, you always want to make sure that everything that you're doing to one side, you're doing to the other side of the equal sign. Right, I see a lot of kids get tempted to do plus 16 here and then plus 16 here and then add 23 and 16. No, right, that doesn't work. Right, you need to make sure that you're doing it on both sides of the equal sign. All right, so let me get rid of that. All right, and then we want to, oh, I don't know why I erased that, right? This is plus 16. And then 30 plus 16 is going to get you 46 equals 23, 23n. And then you want to divide by 23. And then 23 divided by 23 goes away. We get n equals 46 divided by 23 is 2. All right. And then for number 3, again, we want to distribute. So let's distribute 4. Again, don't do 10 plus 4 and then distribute 14, right? It's just distributing first, right? That's what we're doing first. All right, so 7 minus 6m equals 10 plus 4 times 3 is 12. 4 times negative 9m is negative 32m. And then you want to add, combine like terms, right? This time we need to combine like terms. We can combine a 10 and a 12. All right, so that gets us 22 minus 32m. And then we get 7 minus 6m. All right, that's equal to this. And then we can get our variables to one side, constants on the other. All right, so let me go ahead and subtract the 7. Again, it doesn't matter which side you're moving where, right? I'm just going to move the 7. So 7 minus 7, you get negative 6m equals 22 minus 7 is 15 minus 32m. And then let's add 32 on both sides. Or 36, I'm sorry. Let me go back. Yeah, this should be 36. My bad. Okay, so minus, 36. 36. And then 36. Okay, yeah, sorry about that. And then plus 36m. Yeah, that makes more sense. Okay. And then negative 6m plus 36m is going to be 30m equals 15. And then lastly, you want to divide both sides by 30. And then we get m equals 15 divided by 30. That can be simplified, right? They both share a factor of 15, right? So divide the top and the bottom by 15. And then we get m equals 1/2. All right. Okay, let's keep going. Number 4, we can combine like terms, right? So again, you're looking on one side of the equal sign. This side, you can't combine anything, but on this side, you can combine a negative 7 plus 7, right? They both have a k in front of them, right? So a negative 7k plus 7k is going to become 0, right? So that just goes away. So we're left with negative 10 equals negative 6. Now there's no more variable to solve for, right? So what does this mean? Right? This is one of our special cases. So we're looking, what do we have left? Is this a true statement? Is negative 10 equal to negative 6? Right? So is this true or false? All right? And it's going to be false, right? This is a false statement. This is never true, right? So this is no solution. All right? Again, so this is a special case. If the variable just disappears completely, you need to look at what you have left, right? Is this a true or false statement? And if it's false, it's no solution, right? This is never true. All right. So let's keep going. All right, so something like number 5, we want to distribute the 7. So we get 7 times x minus 7 times 6 is going to be 42 equals negative 42 plus 7x. Now you could stop right here, right? Commutative property of addition, right? You can switch the places of these two, right? Switch by commutative property, and then you get 7x minus 42 equals 7x minus 42. And this is exactly the same, right? If it is exactly the same on both sides of the equation, this is all real numbers. This just means you can put in any number for x and you'll get an answer. You'll get a true statement. If you didn't recognize that though, and you didn't flip it, or you didn't just look at both sides and recognize that they're the same, you can keep going. Let's say you wanted to get the 7 to the other side, the 7x, right? So let's subtract 7x, and then we get negative 42 equals negative 42, and then hopefully here it's more clear, right? There's no more x to solve for, and this is a true statement, right? Negative 42 is equal to 42, to negative 42, right? So this is all real numbers. You could also say all real solutions. You can say infinite solutions. You can say it's an identity, right? I've said all of these in class, right? So just any of them, as long as I know that it means that any solution works, right? Anything is fine for this one. All right, let's keep it going. All right, so let's try number 6. Right, so let's get the m's to one side and the constants on the other, right? There's nothing to distribute. There's no like terms to combine, right? Because on each side of the equal sign, on this side, everything's fine, and on this side, everything's fine, right? There's nothing more we can do on each side. So let's go ahead and let's add 7m. All right, and then we're left with 22m plus 22 equals 18. All right, and then let's subtract 22 on both sides. And then we get 22m equals 18 minus 22 is negative 4. And then last thing, let's divide both sides by 22. And then you get m equals -4 and 22 share a factor of 2, right? So let's divide the top and the bottom by 2. So you get -2/11. All right. Let's keep going. All right, again, we're checking on either side of the equal sign. 8x minus 7. Can you combine anything to distribute? No. And on this side, 7x minus 10. Is there anything to combine? Anything to distribute? No. All right, so let's just go ahead and start moving things around. I'm going to move 7x to the other side by subtracting 7x. And then 8x minus 7x is just an x, and then 7x minus 7x goes away. So you're left with x minus 7 equals -10. And then you want to add 7 on both sides. And then -7 plus 7 goes away. You get x equals -10 plus 7 is going to be -3. And there's your answer. All right. Same thing with this one. Right, you look at either side of the equal sign. -n minus 11, can you do anything there? No. What about 2n plus 4? Again, nothing there, right? Nothing to distribute, no like terms. So let's get everything to one side. Right, let's subtract 2n. And then -n minus 2n. -n is the same as -1n, right? If you don't see a number in front of the variable, you assume it's a 1. And then -1 minus 2 is going to be the same as -3, right? If they have the same sign, you add them and you keep the sign. All right, and then 2n minus 2n goes away, and this equals 4. All right, and now let's add 11 on both sides. So then we get -3n equals 15. And then you want to divide by -3 on both sides. So you get n equals -5. All right, let's look at this one now. All right, let's distribute. Here we're going to have to distribute on both sides. All right, so on both sides of the equal sign, right? Is there anything to do on either side? Yes, we have to distribute. So distribute is 7, we get 7 times h is 7h. 7 times 3 is 21. On the other side, 6 times h is 6h. 6 times -3 is -18. Right, equal each other. All right, and then we want to get the constants on one side, variables on the other. Let's subtract a 6h. All right, and then 6h minus 6h goes away. Yeah, h plus 21 equals -18. All right, and then let's subtract 21 on both sides. Then we get h equals -18 minus 21. If they have the same sign, you add them and you keep the sign. All right, so -39. All right, last 3. All right, so let's try number 10. All right, this is one that was in your homework, but I brought it back just because it's a good example. Right, here we want to distribute first. Right, here we're able to distribute a -2. And then once we distribute a -2, we get -2x. -2 times -3 is +6 equals -2x plus 6. And then again, from here, you don't have to do anything else, right? Is it the exact same equation on both sides? Yes, right? This is always true. Always true. So this is all real numbers. All right. And then let's try the next one. All right, first thing we want to do is distribute. Keep in mind, you're just distributing whatever's in front of the parentheses. So it's going to be a -6, right? If there's a minus in front, you want to keep that with it. So then we get 2 plus h equals 7h, and then -6 times h is -6h, and the -6 times 5 is +30. All right, and then we get 2 plus h equals 7h minus 6h is just h, or 1h, plus 30. All right, and let's get the h's to one side. When we subtract h on both sides, though, you're going to notice it's going to go away on both sides. So we get 2 equals 30. All right, is this true? All right, no. This is not true. This is no solution. All right. And then just one more. So we're going to combine like terms. Right, check on either side of the equal sign. -2 plus w, can you do anything to that? No, right? But can you do anything on the other side? You can combine 3w and 2w. So it's going to become 5w minus 6 equals negative 2 plus w. And then you want to get the w's on one side, the constants on the other. All right, so let's subtract this w. And then we get 5w minus w is 4w. Minus 6 equals negative 2. And let's go ahead and add a 6 on both sides. And then negative 6 plus 6 goes away. We get 4w equals negative 2 plus 6 is 4. And then divide both sides by 4. We get w equals 4 divided by 4 is 1. All right. Now that's your review. Again, we had already done this before, but I wanted you guys to have something that you could go back to in case you forget anything, right? And you guys have all of this. We went over most of it in class. All right, but again, all the problems here are completely worked out. If you have questions, you can always feel free to reach out. All right, thank you.